Hola, hello. So today we're going to talk a little bit more about theoretical versus experimental probability. So something we talked about is theoretical probability is what might happen. Experimental probability is when you actually try it, right? So theoretical probability would be like saying, I have a coin, I'm going to flip it. The probability of me getting a heads when I flip it is 1 out of 2. But when I do it, that's an experiment, right? If I actually sit there like I have no life and flip a coin 20 times, that's an experiment. So we're going to look at the difference between those two today. So you've got here a spinner. And by the way, this is exactly, this is a copy of what you're going to be working on today, right? Except you're not going to have a spinner. You're going to have like a different object, but you're going to have an item. You're going to have some results and you're going to have some questions. So watch a video to see how to do it on yours. Okay, so we got this spinner here, right? So I can see that I've got 1, 2, 3 4s. I've got 1, 2 2s. I've got 2 3s, and I've got 1 1, right? That's going to influence my theoretical probability, right? I'm actually not even going to look, and let me get my little focus mouse. I'm not going to look at this table yet. We look at the table when we are actually doing experimental probability. And the first thing I want to do is I just want to think. I want to look at this spinner and I want to think what might happen because that is theoretical probability. Okay. So let's talk about what actually might happen when we are using this. Okay. So I need to figure out, before I do anything, what is the probability of this spinner landing on 1? So how many 1s are on here? 1. So that's my numerator in my fraction. How many total spaces are there? Let's say 1, 2, 3, 4, 5, 6, 7, 8 spaces. That's my denominator in my probability fraction. So the probability of getting 1 is 1 out of 8. Now I do the same thing for the probability of 2, right? I think about how many 2s are there. That's my numerator. And how many are there? 2. Great job. And I'm going to put that over the number of total spaces, which again is 8. So now I have 2 8s. That can be simplified to 1/4, right? Or you could put it in as a decimal or percent form. I'm going to continue doing that, right? So the probability of a 3, how many 3s are there? Over how many total spaces are there? There are 2 3s in here out of 8 spaces. So that's why 2 8s. Probability of spinning a 4? Well, this one might be a little bit different. How many 4s are there over how many total spaces? So if you were thinking 3 8s, you are absolutely correct. Okay. Now I'm thinking, what's the probability of an even number? So how many spaces have an even number over how many spaces total? So that would be 5 over 8. So there's 5 even numbers. And there are how many odd? 3 over 8. Okay, because it's 3 odd spaces out of 8 total. So what's the probability of getting a 1 or a 2? Well, how many spaces have a 1 or a 2 in them? And then put that over the number of available spaces that you could possibly land on. And that would be 3 out of 8. And the probability of getting less than a 4. Not a 4, less than a 4. So for less than a 4, we would have, let's see, 2, 3, 4 out of 8. All right, beautiful. Okay, now I'm ready to do my experiment, right? So here I sat there like I had no life, and I spun this spinner a bunch of times, and I landed on a 1 4 times. I landed on a 2 space 3 times, landed on a 3 space 6 times, and I landed on a 4 space 7 times. So to do experimental probability, your numerator is going to be how many times did you land on it? And then you're going to put it over your total number of tries. So how many times did I land on it? I landed on a 1 4 times. And how do I get my total tries? Well, I'm going to need to add these all up. 4 plus 3 is 7, and 6 is 13, and another 7 is 20. So 4/20ths, which simplifies to 1/5. Probability of getting a 2. How many times did I spin a 2? 3 times. So 3 out of 20. What do you think the probability of doing a 3 would be? Yep, 6 out of 20, which gives you 3 out of 10 when you simplify it. Probability of spinning a 4? Okay, 7 out of 20. Then I'm going to do the same thing for my evens. How many times did it land on an even number? My even number is 2 and 4. 10 out of 20, which gives you 1/2. Probability of an odd, 10 out of 20, which gives you 1/2. How about the probability of a 1 or a 2? So we're going to look, how many times did it land on a 1 or a 2? Well, that was 7 times out of 20 total tries, 20 total spins. And how about less than a 4? Well, 6. It landed on a 3 6 times, a 2 3 times, and a 1 4 times. So that's a total of 13 times it landed on something less than 4 out of 20 total tries. Okay, so is the theoretical probability greater than, less than, or equal to the experimental probability when you're looking at the probability of spinning a 1? Well, the probability of spinning a 1 we found up here was 1/8. Okay, and if I want to compare these, it might be easier to do it in decimal form. 1/8 is 0.125. Okay, which would be 12 times, if it times that by 100, that would be 12.5%. Okay, because it's a little bit easier to compare them in decimals of percents. Over here, for the probability of spinning a 1, when I did the experiment, it happened 1 out of 5 times, which 1 divided by 5 gives you 0.2, which is 20%. So how would I compare them? I would say the theoretical probability up here is what compared to the experimental probability? Yeah, it's less than. Okay, and here's the deal. What would you expect after more spins? Believe it or not, you would actually expect that the theoretical and the experimental would get like a little bit closer together, right? If so a little bit interesting, right? If you can, do the challenge. If not, no worries. Do what you can. Let us know if you have any questions. Love you. Bye.